Hello, so this is a demonstration of the ECAN module on PIC24 EP devices. Okay, so here I will be demonstrating the issue that you are having on your ECAN module. So basically, based from your description, it seems that when you send 0 by 303 data to the ECAN module, it looks like it corrupts the data for 0x302 filter. So here I created a demo code to simulate your issue, so I was able to uh, duplicate it using your setup. So first I copied your configurations. So I have here your oscillator settings, sorry, here, and I defined it as customer settings. Okay, so then in your oscillator I also reconfigure this the way you are configuring it in your setup. Okay, next is let's go to the ECAN module. Okay, so here's the inputs to our ECAN module. So first I configured the bitrate to 250 uh, kilohertz or bits or baud. So I declared three filters, same as yours. So 0 by 302, 0 by 40B, and 0 by 303. I declared one mask, which is 7FFF. So basically, it needs to match the filters. So never mind this one because we're not going to transmit. Okay. Next is how to configure the ECAN. So here are the steps. Go first, need to go to the configuration mode. Then we need to set the bitrate. So the bitrate here is the 250 bits baud. Okay. So I set clock selection bit to 000. That means the FCAN would be equal to the peripheral clock, which is half of the system clock, which is 8 megahertz. So FCAN would be 4 megahertz. So based from your settings, here's your time quanta. If you add the sync segment, propagation delays, phase segment 1, phase segment 2, the bit time would be 8 time quanta. And the bit rate would be calculated this way and implementing that in the code. This will be the settings. Okay, so BRP val. Okay, so same as your settings again. So you have declared 4 buffers, and for that 4 buffers would be all transmit buffers. You don't have transmit buffers, and the transmit buffer starts at buffer 0. So that should be consistent here. So assigning how to assign the buffer to the ECAN module. So So I declared, sorry, this should be 4, and it should start at buffer 0. Okay, so I initialize DMA 0 and DMA 2. So basically I use DMA 2, okay, for the receive. So here's the settings for the DMA, and enable the ECAN. Okay, so here's my setup. So I have here a Explorer 16 with the SPIC33 EP512 MU810, which is in the same family of the PIC24 EP here. It says here in the datasheet they are in the same family. Okay, so here's my setup. I have here my Explorer 16. I have here my Explorer 16, and then I have here here's the CAN transceiver module, and here's my CAN bus analyzer. Okay, and here I'm using the Optimizer Studio to send CAN data. Okay, so let's try to simulate what you are experiencing. So I'll try to send 302 data. Okay, okay. So you can see in the LCD it displays the CAN ID. Well, basically that's the filter ID and the data that has been received. Okay, so I'll send this activity number 2, which is for identifier 40B. Okay, as you can see in the ID that it changes, and also the data. What would happen if I would send 303? As you can see, the data has been changed, but the ID, instead of showing 303, it shows 302. So what would happen here is that instead of having the data to be filtered by filter 30B, it has been filtered by 302. This is the reason why in your setup is that you are seeing that the the buffer for filter 302 is being corrupted by the data, or being overlapped by the data that is being sent using CAN ID 303. So the ECAN module was not able to filter it correctly because of this, because of the time quanta and the bit rate. Here the time quanta, here the time quanta and the bit rate. So because if we try to check on the value of the BRP here, the BRP val, it would be equal to 0. Okay, so okay, so you can see here, VRP val would be equal to 0, and the time quanta of 8 is not enough to filter it correctly. So what I did is that, okay, I have here the customer settings. So if I would remove that defines, I'll just destroy it. Okay, so by destroying the customer settings define, basically what I did here is to use a oscillator frequency of 80 megahertz rather than 8 megahertz, and that I used here. I used FCAN would be equal to 40 megahertz, and I used a time quanta of 20 rather than 8. So that is the difference between those settings. So when I try to program this code, okay, it's done. So as you can see here, so if I send a data or a message with CAN ID 302, you can see here, so that the ID would be 302 and the data would be here. If I send a CAN message with 40B, should receive 40B here, and here's the data. So if I send 303, I should be receiving 303 here. So now if I use the settings the settings that I modified, I now receive it at as 303, not 302. Okay, so with that, I'll just send this demo code to you and try to use this as a reference.